In our previous video, we looked at calculating an unknown side using the three trigonometric ratios sine, cosine, and tangent. Today we're going to look at how to calculate an unknown angle using the same three trig ratios. So a quick recap, we can only use these three ratios on right angle triangles. And a recap of the formula: SOH, sine is equals to opposite over hypotenuse, CAH, cosine is equals to adjacent over hypotenuse, and TOA, tan is equals to opposite over adjacent. Now when you're finding the missing angle, you would have to use the sine inverse, the cosine inverse, and the tan inverse. And in some cases you would see it as arc sine, arc cos, and arc tan. Now to find these three functions, sine inverse, cos inverse, and tan inverse, you would have to use the second function on your scientific calculator, and you would find them right above the regular sine, cos, and tan button on the calculator. So look for them, and let's go into some examples on how to use them to find the missing angle. So our first example, you have a right angle triangle here, and we have to calculate the size of angle ACB. Now when you're given the angles like this, ACB or ABC or XYZ or whatever it is, the angle that we're actually trying to find would be the angle that is at this letter in the middle, right? So the angle we're looking for would be the angle at C. So if we draw our little man here, and I'm standing there, then this side becomes my opposite side, and this side that is below me becomes my adjacent side. So we're looking for a ratio with opposite and adjacent. Since there is no hypotenuse, therefore these two are out. So we're working with the tan. So tan theta is equals to opposite over adjacent. So let's write down what we have. Theta, we don't know. Our opposite side is equals to 8.7 cm, and the adjacent side is equals to 10.9 cm. So let's go and find what is this angle. So we're using tan. Tan theta is equals to opposite over adjacent. Tan, let's not put a question mark here. Let's call theta C, right? Because this is what we're finding. So tan C is equals to opposite, which is 8.7 cm, over the adjacent, which is 10.9 cm. We put this over 1 and then we cross multiply. So 10.9 times tan C would give me 10.9. Tan C is equals to 1 times 8.7 is going to give me 8.7. Now we want C, right? Make this a big C. So the operation between tan and this 10.9 is multiplication. So to get the 10.9 on the other side, we have to divide it out because we always do the opposite operation. So we divide this side by 10.9 and we do the same across here. So this and this would cancel out each other, leaving tan C is equals to 8.7 divided by 10.9. So we're going to work that out. 8.7 divided by 10.9, and that's going to give me 0.798165. So let's use like 5 or 6 numbers here, right? So that we be as accurate as possible. Now we don't want tan C, we want the value of C. So these two are being multiplied to get the tan across here, therefore we'd have to divide here by tan, and then it goes at the bottom, and then we apply a laws of indices to take it up to the top. So I'm not going to confuse you with all of that. So we're going to say C is equals to, and then we take the tan across, it becomes tan inverse 0.798165. C is equals to, so now we have to press second function, or in some calculators shift, tan 0.798165, and it would give me an angle of 38.59. Round off to one decimal place. C is equals to 38.6 degrees. So the angle here is 38.6 degrees. Example 2. So we have another right angle triangle, and we have to find the size of the angle BAC. Again, remember the angle that we're actually trying to find would be this middle one. So we're trying to find the angle at A. Now, if I'm standing here, we're looking at what is given. So one of the sides given would be this one, and since I'm standing here, this becomes my opposite side, and the side that is opposite the right angle becomes my hypotenuse. Now let's see what is given. So theta, we'll call that A. The hypotenuse is 15.4 cm, and my opposite side is equals to 8.70 cm. Now we have to look for the trig ratios that carry hypotenuse and opposite. So looking at it, sine is equals to opposite over hypotenuse. So straight off, you know, we're working with a sine. Now sine theta is equals to opposite over hypotenuse. Sine, we know that theta is A, is equals to the opposite side, which is 8.70 cm, divided by the hypotenuse, which is 15.4 cm. We put this over 1 and then we cross multiply. So 15.4 times sine A would give me 15.4 sine A is equals to 1 times 8.70 would give me 8.70. Again, we move the 15.4, so we divide here by 15.4, and what we do on this one side, we do the same across here. This and this would cancel out, so sine A remains, and that is equals to, you divide these two, which should be 8.70 divided by 15.4, and that's going to give me 0.564935. Remember, again, we write like about 6 numbers. Now we don't want sine A, we want A alone. So A is equals to, we take the sine across, it becomes sine inverse of 0.564935. A is equals to, we go second function or shift, sine 0.564935, and that's going to give me 34.39 degrees. Round it off to one decimal place. A is equals to 34.4 degrees, and that's the size of the angle at A. Alright, our third example. So we have to calculate the side of angle ABC. Now remember, we have to find the angle at the middle, so that means we're trying to find this angle. So if I'm going to stand here, then this side that is given, the side that is below me or next to me, is called the adjacent side, and the other side that is given is opposite the right angle, so this becomes the hypotenuse. So we have to find one of the ratios that carry adjacent and hypotenuse, and that would be cosine. So let's see what is given. Theta is equals to B. The hypotenuse is equals to 9.41 cm, and the adjacent side is equals to 6.85 cm. So we're working with cosine. So cos theta is equals to adjacent over the hypotenuse. So cos, we say that theta is b, is equals to the adjacent side, which is 6.85 cm, over the hypotenuse, which is 9.41 cm. We put this over 1 and then we cross multiply. That would be 9.41 times cos b. That would give me 9.41 cos b is equals to 1 times 6.85 is going to give me 6.85. We're finding for b, so we divide here by 9.41 first, and then we divide here by 9.41. This and this would cancel out each other, leaving cos b. So cos b is equals to, we divide these two, 6.85 divided by 9.41, and that's going to give me 0.727948. We want the value of b, so b is equals to cos inverse of 0.727948. b is equals to, we use the calculator, second function or shift, cos 0.727948, and that's going to give me 43.28 degrees. Rounding it off to one decimal place, we would have 43.3 degrees. A little recap. So our three trig ratios, SOH, CAH, and TOA, so katoa. Sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. We use these three trig ratios to find unknown angles and unknown sides in right angle triangles only. We use sine inverse, cos inverse, and tan inverse when we're finding a missing angle. We could find the inverse by pressing second function on some calculators, or shift on some, and then you press sine, and that's going to give you sine inverse. You would see sine inverse in some calculator, or you would see arc sine in some calculators.